Continuing with chemical thermodynamics, bottom of page 62 to the top of page 64. So entropy is represented with the letter S as the abbreviation, and what this stands for is it's a measure of order and disorder, and the units are going to be joules per Kelvin mole. The larger the value of S, the more disorder there is. So a lot of people use the term chaos, which is not preferred in the wider scientific community, but the more chaotic the particles are moving, or the more chaotic a solution or a system is, then the larger the entropy value is, or the greater the S. The smaller the entropy value, the more orderly it is. So say if you take molecules and you cool them down, they start moving slower and slower, and the slower they get, the more orderly they become, like in a solid, and then this would be a small value of S. So entropy, or S, of a system is a state function, if you remember back the difference between a path function and a state function. So we have two different processes to consider: irreversible and reversible. So all spontaneous processes occur irreversibly, meaning only the forward reaction is spontaneous, but the reverse reaction is not. The falling ball, in our example of the previous video, is a reversible process. The process will never spontaneously go in reverse. Another example would be if you had ice melting at room temperature. So if you have ice remains frozen at 0 degrees Celsius, but if you have ice sitting in 25 degrees Celsius and 1 atmosphere, then you would expect it to start melting. So it would spontaneously begin to form water. So ice will melt at 25 degrees Celsius and spontaneously forward start becoming water. At 25 degrees, the water is not likely to go in the reverse direction and spontaneously start becoming ice again. So once the ice has melted, it cannot go backwards to ice at a temperature of 25 degrees and 1 atmosphere. So this is spontaneous in the forward reaction, but not spontaneous in the reverse. So it's an irreversible process. A reversible process, however, will take place when you have a state of equilibrium. And that's going to be really important going forward. At the normal melting point of water, so I really want us to kind of focus on, when you see the words normal melting point, or normal boiling point, or normal freezing point, anytime you are talking about a phase change, you are talking about a system that is in equilibrium. So all phase changes occur at equilibrium. This process can be exactly reversed at 0 degrees 1 atmosphere. So in other words, if we have a temperature of 0 degrees Celsius, then during that temperature, ice can turn into water by melting, or the water can turn back into ice by freezing. It just depends on if you're adding heat or if you're removing the heat. So adding heat will melt the ice, removing the heat will freeze the water. We can reversibly convert from all ice to all water by adding heat, or we can remove the heat in a series of steps and convert all the water back to ice. If I'm adding heat, then we can turn the ice and get it to melt and turn into majority water, or I can remove heat from this system, and over time then you would have more ice and less water. A reversible process occurs at equilibrium, in this case by adding and removing very small amounts of heat.